do the first experiment of sodium chloride in water, and you're going to use a microscope slide instead of a watch glass. So you'll need to make that change in your materials section. You'll use a glass slide instead of the watch glass. That's because the watch glass will shatter when it's heated. So make that change in your materials section. Alright? And then when you come up here to get your 2 to 3 milliliters of water, you have to know that you're walking away from the counter with exactly 2 or 3 milliliters of water. So what are you going to use to do that? Hopefully you just said the graduated cylinder. So you're going to bring your graduated cylinder up here. Does it make sense to pour from a gallon jug into a 10 milliliter graduated cylinder? No, you don't have a lot of control that way. So you need to also bring a small beaker with you. You pour the water into the beaker first, then you can pour the water from the beaker into the graduated cylinder. And measure out your 2 to 3 milliliters, dump out the excess water from the beaker, pour the 2 to 3 milliliters from the graduated cylinder into the now empty beaker, and then you can mix in your sodium chloride. Now how are you going to get the sodium chloride out of this beaker here? You'll need to bring your scoopula with you to the countertop in order to do that. Okay, so let's do the first experiment. Alright, now let's add some water to our small beaker. This is distilled water, which means that there's no impurities in it. It's 100% pure water. Okay, so now we will transfer 2 to 3 milliliters of this into our graduated cylinder. Okay, so we're over 3 milliliters, so we need to take some of that back out. So we can use our pipette to do that. Let me just take some of the water out of there. Alright, there we go. Now we'll pour out the excess here. Pour our 3 milliliters of water back into this beaker, and then we'll get some salt for it. So use our scoopula to get some salt, and here's about as much salt as we need on there. Hopefully that you can see all that. Okay, so we'll pour that in there, and then we need to dissolve this. Alright, so in order to fully dissolve it, we're probably going to need to use our stirring rod, our glass stir rod. So let me see if I can get my hand out of the way for you. Alright, so we're just mixing that up. Okay, so after a lot of stirring, not all of the salt is dissolved, which means we need a little bit more water. So I'm going to go get a little bit more water. Okay, so we've got all of the salt dissolved in our beaker now, and now we're going to put just a couple of drops of this on a microscope slide. Okay, so we got a clean microscope slide from the supply table, and now we're going to put some of our saltwater solution on it. Just a couple of drops. Okay, so I don't know how well you can see that, but we've got a little drop of that saltwater solution on there. Alright, so let's light our Bunsen burner. Okay, so when we heat something on a glass slide or a test tube over the Bunsen burner, you're going to pass it in the flame and then out. So in and out. And that way we keep the glass from getting too hot and give it a chance to kind of cool down a little bit. And I'm using my forceps to hold the glass slide. Okay, I'm not putting it in the hottest part of the fire, I'm just passing it over the top. So here's what's happening to it so far. Let's keep going. So there is the final result. All right, let's get a close-up of that. Okay, so here's kind of a close-up. Let's see if we can look underneath the magnifying lens at it. See if I can get any closer here. Alright, so here's as close as I can get you to it. And now let's look at a normal sample of salt. Okay, so here's fresh salt that hasn't been dissolved before. Okay, so this is the original, and this is the new kind. So you need to make your observations and then decide, was there a chemical or a physical change here? Okay, now we got to wash our microscope slide off with soap and water. Our beaker that we got the salt water in has to be washed with soap and water as well, and we're using our test tube brush to clean it out. Okay, so we're going to start by screwing the standard into the countertop adapter, which is this piece right here. And then we'll put that in the countertop. And we can assemble our Bunsen burner. Okay, so the next experiment that we're going to do is to heat up the copper turnings. So we have our crucible here, which is what this is. Now, crucibles are made of porous material, which means they absorb moisture from the air, and they can even absorb oils from your skin. So they have to be dried. And by dried, we mean heated up. Okay. Now, if you go straight to heating them at the Bunsen burner's strongest setting, which is the tip of the inner cone, you'll shatter this. So we have to set this up pretty high away from the Bunsen burner's flame just to let it warm first, and then we can start lowering it. Okay, so we have the crucible up here at the top, and we've got our ceramic tile here because we never set anything hot directly on the countertop. We always set it on the ceramic tile instead. Alright, so I'm going to go ahead and light the Bunsen burner and put that underneath the crucible. Now we want it to be warm up here, so I can feel the warmth up underneath the crucible, and we're going to leave it there for about 2 to 3 minutes. Now we want to move the ring stand lower. You have to take the crucible off, because any time that we lower something on the ring stand, you must remove the crucible, because if it bumps, it could knock the crucible off and then it would break. So you're going to use your crucible tongs to do that. Right here on the inside of these two grippers, there's some serrated edges, so it's kind of a rougher surface. And we really actually don't need to even heat the lid of this crucible, because that's not going to be in the experiment. So you would just grab the crucible, take it off of the iron ring, and set it on the ceramic tile. Okay? So for right now, I'm going to let that heat up for the next 2 to 3 minutes. I wanted to give you a closer look at the setup here. We have our ring standard. We have the iron ring attached. We have our clay triangle sitting across the top of the iron ring. And then the crucible is in the center of the clay triangle so that it doesn't fall through the iron ring. Okay, let's talk about these copper turnings here. This ball has just been rolled up of all these tiny little copper turnings, which are actually just very, very thin wires. If you try and pull on this, it can slice through your skin, so you never pull on these copper turnings to try and untangle them or anything like that. And you also don't squeeze on them very hard, because they could poke through your skin. So you just be very gentle with these copper turnings. Alright, this crucible's been heating up for about 3 minutes now. So I'm going to go ahead and take this off, set it down there, and now I need to move the iron ring. Well, once the Bunsen burner has been turned on, you never touch anything with your bare hands anymore, because that could be hot. So I'm going to use these crucible tongs here to sturdy the edge of the iron ring. Okay? Let's see if I can get you a better angle. Alright, so then I'm going to lower this down, And I'm going to lower it down so that the bottom of the crucible will be sitting at the tip of the outer blue cone. Okay, not the inner one, but the outer one. Okay? And then I'll put my crucible back in the clay triangle. And we'll let it heat up here for another 2 to 3 minutes. We'll come back when that's done. Okay, so this has been heating for another 3 minutes. So I will take this off. And then I need to lower this down so that the bottom of the crucible will be at the tip of the inner blue cone. So I'm going to use these to stabilize the iron ring. Lower that more. And then put the crucible back. Alright, so now we're going to let this heat up at the hottest setting of the Bunsen burner for another 2 to 3 minutes, and then we'll come back. Alright, notice here that the bottom of the crucible is glowing a red-orange color. That means that we have reached the temperature we need and that this is now dry. So, we're going to take the crucible off of the Bunsen burner again, and we're going to let it cool down. And then after it's cooled down, we will put our ball of copper turnings in it, and we'll get the mass. You never mass anything that's hot, so this crucible here is going to have to cool down before we can use it. Now, how do we know that it's cool enough to be used? Well, you take the back of your hand and hold it near the crucible, and if you can feel any heat at all, it's too hot. Okay, and so I can definitely feel a lot of heat coming off of there because we just took it off. So I'll come back when this is cool enough to be masked. Okay, so I now have the copper turnings inside of my cool crucible, and we're going to put that on the tray of the balance here, and then we need to balance this. Okay, so we start by moving the heaviest one first. That's too much. Then we move the middle one here until it falls down. Okay, so 30 is too much, so we back it up to 20. And we move this one. Okay, so that one is too much. So then we will go through and slide this very bottom one until it falls down. Okay, so we've got them pretty even, so let's look at our measurement. Okay, so we have 20.01, 015, 016, 017, and it's a little bit after 017, so I'm going to say 017.2 or 3, so it's going to be 20.172 grams. Okay, so we're going to light the Bunsen burner again, and then we're going to slide it back underneath the clay triangle here, and then we're going to put the crucible with the copper inside of it on the clay triangle. Okay, so let's put this on the clay triangle, and then watch what happens to the copper. Okay, so hopefully you made note of that reaction there. And now we're going to take that crucible off and put it back on the ceramic tile so that it can cool down. And then we will turn off the gas, making sure we don't reach over the top of the Bunsen burner when we do that. And then the crucible has to cool back down again so that we can go get the new mass on the triple beam balance. So we'll come back when the crucible's cool. Okay, so now we're going to take our cool crucible with the burned copper and put it on our weighing tray. And then we'll go through our process again. So we'll do the biggest one first. And that's too much, so we back up. And we do this middle one. That's not enough. So that's not enough. Alright, so then we back up to 20 again. Okay, then we can move this one to the 1 position. That's too much. Okay, so then it's going to be the small one again. Okay, so let's move this a little bit. Alright, that looks pretty even to me. So I know it's a little bit above, but for our purposes we're going to say that's good. So let's get our measurement then. 20.15169. That looks like 20.169 to me. Okay? So you should be able to say something about the mass of the crucible before and after. That's also an observation. Remember, that's a quantitative observation because it deals with numbers. Alright, so disposal for the burned copper goes in the beaker labeled burned copper on the front counter. I just wanted to give you a comparison side by side of what those two look like so that you can see for sure that there was a change there. Okay, so we'll put this one in the burned copper. Okay, so now to put everything away, this crucible and the lid never get washed with soap and water. At most they get wiped out with a damp paper towel, but even this time they really don't need that because there's nothing that the copper left over in there. So we'll put those back in the breakables drawer and set up for the next experiment. We're going to get our utility clamp and put that on the ring stand. The utility clamp clamps onto the ring stand here. Then this wing nut here allows you to control the angle that a test tube can be tilted at. Okay, and then this wing nut right here will control these two little arms here that will clamp down around the test tube. Okay, so now we want to get a few crystals of this cupric sulfate, which is the CuSO4. So we're going to unscrew that, tilt it to the side to collect a few crystals, and that will then put in our test tube here. Okay, so here's what we ended up getting inside the test tube. We don't need a whole lot, that's plenty. And then if we're the last ones to walk away from the countertop, we always need to put the lid back on the container because a lot of our chemicals, like this one, can absorb water or moisture out of the air, and then that'll ruin them. So we always put the lid back on. Okay, so we're going to put the test tube inside of our utility clamp and fasten the utility clamp around the test tube. Now there are really two ways to go about heating this test tube. We can set it up like I've done here in the utility clamp, and then you've got your Bunsen burner, and you're going to use the Bunsen burner like a paintbrush. So imagine that this Bunsen burner was on, and you're just going to paint all around the test tube with the flames of the Bunsen burner, and then take it away from the test tube for a minute so it can cool down and not shatter, and then come back and paint with the fire a little bit more, and then take it away. The good thing about this is my hand is underneath the flames the whole time, and so I'm in much less danger of being burned. The other way to do it is to put the test tube inside the test tube holder and light the Bunsen burner, and then just like we did with the microscope slide, you pass the test tube into the flames for a second and then out of the flames, and then back in and then back out. Either method is fine, although this method gets your hand a lot closer to the flames, and so that's why I prefer using the utility clamp up here instead. So that's the method that I'm going to use. So let's light the Bunsen burner, and then we're going to use the flames like a paintbrush and heat this up, and we want to watch what happens to those blue crystals inside there. Okay, here we go. I want you to see what's happening up here at the top of the test tube. Some kind of a vapor is escaping and then condensing up at the cooler end of the test tube. Okay. Alright, so let's go back down here. Okay, so let's turn the Bunsen burner off. Okay, so here's the crystals up close now. So they started out that kind of a royal blue color, and here's where we ended up. They're like a chalky white color now. Okay, so you can write that observation down. And the next step says to add some drops of sulfuric acid, dilute sulfuric acid. So we're going to do that next. So you'll notice that each of these beakers has their own pipette. So you would not bring your pipette up here, you would use these instead. Because if you brought your pipette up here and took some of this and then stuck your pipette in the next beaker for the next experiment, you might cause a reaction to happen and you would ruin the stock solution for everybody else. So we're going to use the pipettes that are specifically for these solutions. Okay, so I'm going to hold this up here and I'm going to put in a few drops of that sulfuric acid so that you can see what happens. Alright, so hopefully you can see that there's been another color change here, and that color change has kind of gone back to that royal blue color from the beginning. Okay, and then it says to heat it back up, so we're going to start the Bunsen burner again, and we paint with the flames again. And we want to make sure that the test tube is not pointing at anybody's face, and that we're very careful when we heat it so that we don't cause the liquid to splash out of the open end of the test tube. Alright. So then we can come back and look at these again. And hopefully we can see here that they've changed back to that blue color, and now they are a solid again. There, so we've got that blue color again, and they're solid crystals again. Okay, so write your observations down about that. Okay, so now it's time to clean that up. So we'll wash that test tube out with soap and water using the test tube brush, and all of that can just go straight down the drain, and then we'll move on to the next experiment. Okay, so for the next experiment, we're going to take 5 drops of the iron 3 chloride, and we're going to add 3 drops of the potassium thiocyanate. So this is the FeCl3, and it is a yellow color. And then we have the KCN, and it's a clear color, so it just looks like water. Alright. When you use a pipette, you never ever turn the pipette upside down like this, because then liquid can run into the bulb and you'll lose suction. Okay? So always keep the pipette vertical. Okay? So we're going to suck up some of this, and then when we get ready to put it in the test tube, we're going to make sure that we don't touch the pipette to the inside of the test tube, because if we do that with the next pipette, we can cause a reaction that would go up into the pipette itself. Okay? Alright, so 5 drops. 1, 2, 3, 4, 5. Okay, and now we're going to add the 3 drops of the potassium thiocyanate. And I guess I'm going to do it back here so that you can see the reaction in the test tube. Let me stand in front of it like this. You got a good background now. Okay, here we go. 1, 2, 3. Alright, so here we have this reaction. It's kind of a, let's see if I can stand in front of it for you. It's kind of like a deep red color, so like a crimson type color. Okay? Okay, so last experiment, we have a new clean test tube. We've got the iron 3 chloride again, and now we have silver nitrate, AgNO3. Again, this one is a clear color solution, so it looks like water as well. All right. So we're going to get 5 drops of the iron 3 chloride. So 1, 2, 3, 4, 5. And then it says to get 2 drops of the silver nitrate. So put this up here so that you can see it. Alright, here we go. 1, 2. Alright. Let's see if we can focus this up. Hopefully you notice that there's some kind of a powder in there now. There's a precipitant in there. That's why it's cloudy and not a translucent solution anymore. Okay. Alright, so that means that a precipitant was formed. Alright, maybe you can even see floating on the top there. There's some white crystals, some white powder looking stuff floating on top. Alright, so then let's wash this one up. Okay, so now we can take our gloves off, and then everybody has to wash their hands with soap and water before you're allowed to leave the lab. And then the last things you take off your face are your goggles when you're ready to walk out of the lab area. Okay, so both my drawers are locked and all my stuff is put back in there, and now it's time to put my goggles in the sanitizing cabinet. Alright, so notice how all of the goggles are put away neatly. And so I will put my pair away neatly as well. Okay? Thank you for joining me with lab today, and I'll see you next time.